At 2320 hours on June 5, 1944, Commander William Tennant stood on the deck of HMS Centurion, watching 47 engineer companies move into position along the Normandy coast. Each company carried identical orders: construct functional boat ramps before sunrise, total time available, 7 hours. Total ramps required, 14. Total previous experience building ramps under combat conditions in darkness, 0. Behind him, the largest invasion fleet in human history spread across 50 miles of English Channel. 5,000 ships, 156,000 men scheduled to land in 6 hours. Every single one of them would need those ramps. The engineering challenge was absolute. Each ramp required 180 tons of interlocking steel sections. The sections had to be unloaded from ships, transported through surf, anchored against tide, assembled underwater in complete darkness, and tested for structural integrity. The ramps had to support 30-ton Sherman tanks driving at speed. They had to function in 6-foot swells. They had to last weeks under constant use. Tennant had 7 hours. The German Wehrmacht had spent 4 years fortifying these beaches. Field Marshal Erwin Rommel personally designed the Atlantic Wall defenses. 4 million cubic meters of concrete, 50,000 obstacles embedded in tidal zones. The defenses were formidable, but they contained one critical assumption. Any Allied landing would require existing port facilities. Capture a port, or the invasion fails within 48 hours from lack of supplies. The Allies had no intention of capturing a port. Instead, British engineering teams developed a radical solution: build the port infrastructure directly onto the landing beaches. The system was called Mulberry, but the foundation of everything was simpler: the EBR, or emergency boat ramp. These weren't crude wooden planks. They were precision-engineered steel causeway sections, each piece manufactured in British factories over 18 months. The problem was assembly time. In training exercises on British beaches, engineer companies took 14 hours to construct one ramp in daylight, in calm seas, with no enemy fire. The War Office calculated that 14 ramps were minimum requirement for Utah and Omaha beaches combined. The math was crushing: 196 hours of construction time needed. Time available, 7 hours before dawn, exposed everything to German artillery. Major Alan Beckett proposed the solution in March 1944. Don't build sequentially, build simultaneously. Assign separate companies to each ramp. Coordinate by radio silence and precise timing. Pre-position all materials on specialized landing craft. Execute like a factory assembly line, but spread across 8 miles of hostile coast. The plan required perfection from 1,800 engineers who would never see each other in the darkness. Tennant gave the order at 23:45. 47 landing craft detached from the main fleet. Each craft carried 16 steel causeway sections, weighing 4 tons apiece. The sections were 10 feet wide, 40 feet long, with interlocking connectors on all 4 sides. Crane operators had already positioned them for rapid deployment. Everything depended on speed. The first craft reached Omaha Beach at 00:15 hours. Captain Douglas Morrison commanded Company C, 467th Engineer Battalion. His target, construct Ramp 6, designated for Sherman tank deployment, 200 yards east of the Vierville Draw. Morrison had 47 men. The water was 42 degrees Fahrenheit. Visibility was 15 feet. Morrison's craft grounded at 00:18. Ramps dropped. The first causeway section slid into the surf. 8 engineers guided it through chest-deep water. The section weighed 4 tons, but floated with neutral buoyancy in salt water. They positioned it parallel to the beach, 30 feet from shore. 4 men dove underneath with pneumatic bolts. The anchoring system used 8-foot steel spikes driven into sand by underwater compressed air tools. First section secured, 00:26 hours, 8 minutes per section. They needed 12 sections total. 96 minutes if everything went perfectly. Nothing went perfectly. At 00:34, Company H lost their second causeway section to tidal current. The section broke free from guide ropes, drifted 100 yards east. Grounded in soft sand, 6 engineers spent 22 minutes recovering it. Behind them, Company K was ahead of schedule, already anchoring their 4th section. The ramps were taking shape at different rates across the darkness. Radio silence prevented coordination. Each company worked blind, trusting the others were keeping pace. The German 352nd Infantry Division held positions 400 yards inland. They heard machinery noise, metal scraping, muffled English commands. At 0047, Oberleutnant Fritz Hartmann ordered illumination flares over the beach. 3 flares arced into the sky. The entire construction operation lit up in harsh magnesium white. Hartmann saw the ramps. He counted 11 separate construction sites, hundreds of engineers visible in the surf, steel structures already extending from beach into deep water. He immediately understood what he was seeing. The Allies weren't looking for a port. They were building their own invasion infrastructure on the beach itself. He reached for the field telephone to contact regimental headquarters. The phone line had been cut by French resistance saboteurs at 23:15 hours. Hartmann's report never reached German high command. The flares burned for 47 seconds, then fell into the ocean. Darkness returned. Morrison's team kept working. They were on section 7 of 12. The eastern ramps were ahead. The western ramps were behind. There was no way to know if they would finish in time. At 0120, a new problem emerged. The tidal flow at Omaha Beach runs east to west, at 2.3 knots during incoming tide. The causeway sections, despite anchoring, were experiencing lateral stress. The interlocking connectors, designed for vertical load, not horizontal current, were showing strain. 2 sections in Company D's ramp separated at the connector joint. The entire ramp structure pivoted 15 degrees off-axis. Lieutenant James Crawford made an immediate decision. He ordered his men to install diagonal support cables between sections. The cables weren't in the original design specifications. Crawford improvised using steel winch line from the landing craft. It worked. The sections stabilized. Other companies, seeing the problem, implemented the same solution. The ramps grew stronger through battlefield adaptation. By 0200 hours, 9 ramps were functionally complete. 4 were still in progress. 1 had fallen catastrophically behind. Company M, working on Ramp 14 at the eastern edge of Utah Beach. Their landing craft had grounded 150 yards offshore instead of the planned 40 yards. Every causeway section had to be manually hauled through deeper water. They were on Section 5 of 12. Dawn was 3 hours away. Captain Paul Yates commanded Company M. He had 2 choices: abandon Ramp 14 and consolidate engineers to help other companies, or commit everything to finishing. Yates calculated the math. Utah Beach assault wave included 32 tanks from 70th Tank Battalion. The existing 13 ramps could theoretically handle the load, but any ramp failure would create immediate bottleneck. Tank crews would be exposed on the beach. Casualties would spike. Ramp 14 wasn't optional. Yates ordered double shifts, every available man into the water. No rest periods, maximum effort until completion or complete exhaustion. His men were already working in 42-degree water for 105 minutes. Hypothermia was setting in. They kept working. At 0245, Company M finished Section 9, 3 sections remaining. They had 75 minutes until nautical twilight, when German artillery observers would gain visibility. Yates pushed his men harder. Section 10 took 14 minutes. Section 11 took 11 minutes. They were moving faster as exhaustion deepened, muscle memory and desperation overriding fatigue. The final section slid into position at 318 hours. Engineers bolted the connectors. Divers secured the anchors. A test team ran the full length of the ramp, measuring stability. The structure held. Ramp 14 was operational. At 0324 hours, Commander Tennant received confirmation. All 14 ramps complete and verified. Total construction time, 5 hours, 39 minutes. They had beaten Dawn by 96 minutes. The first test came at 0630. Dday Sherman tanks from the 741st Tank Battalion approached Ramp 3 on Omaha Beach. Each tank weighed 33 tons fully loaded. The ramp design specified 30-ton maximum capacity. There was no alternative. Lieutenant Bob Garcia drove his tank onto the ramp at 4 miles per hour. The steel causeway flexed, held, supported the full weight. Garcia's tank reached the beach. Behind him, 31 more tanks crossed without incident. The ramps didn't just work, they exceeded specifications. Over the next 72 hours, the 14 emergency ramps handled 1,847 tank crossings, 3,200 vehicle landings, and 47,000 tons of supplies. Not a single ramp collapsed. Structural integrity held at 97% efficiency. The improvised diagonal support cables implemented during construction had increased load capacity by 22%. German intelligence finally received confirmation of the ramps at 1400 hours on June 6. Major Hans Kramer, Wehrmacht intelligence staff, reviewed aerial reconnaissance photographs from Luftwaffe overflights. He saw the ramps clearly. 14 separate structures, fully operational, supporting continuous landing operations. His report to Oberkommando der Wehrmacht included one assessment. Allied engineering capability has been severely underestimated. They have eliminated port dependency. Containment of the beachhead is no longer feasible. The German High Command had based their entire defensive strategy on one assumption: deny the Allies port access, and the invasion collapses within 48 hours from supply starvation. The emergency boat ramps destroyed that assumption in a single night. The Allies didn't need Cherbourg, they didn't need Le Havre. They built their supply infrastructure faster than German intelligence believed possible. The strategic impact was immediate. Field Marshal Rommel requested emergency reinforcements to destroy the beach infrastructure before it could be expanded. The reinforcements never arrived. Hitler believed the Normandy landings were a diversion and kept reserve panzer divisions north near Calais. By June the 8th, the beachhead was irreversible. The 14 ramps had bought the Allies enough time to establish permanent positions. What shocked German intelligence most wasn't the engineering itself. German military engineers were highly capable. What shocked them was the coordination. 47 separate companies executing simultaneous construction in darkness, under combat conditions without central radio communication. The level of planning, training, and trust required was beyond Wehrmacht organizational doctrine. British military planners had spent 18 months preparing for this single night. Every engineer trained for 200 hours on causeway assembly. Every piece of equipment was tested in conditions matching Normandy beaches. Every contingency was mapped. The diagonal support cables that Crawford improvised, those cables had been included in the landing craft cargo list as emergency materials. The planners anticipated field modifications. The 14 ramps weren't genius improvisation. They were the result of systematic preparation meeting perfect execution. By June 9th, Allied engineers had expanded the emergency ramps into full Mulberry Harbour systems. By June 19th, the artificial harbours were handling 7,000 tons of supplies daily. The original 14 ramps remained operational throughout, serving as foundation for the larger infrastructure. Some sections stayed in place until September 1944, supporting operations for 106 days straight. Total casualties during ramp construction: 4 engineers killed by German mortar fire, 17 wounded, 31 treated for severe hypothermia. Out of 1,800 men working in darkness under enemy observation for 6 hours straight, the survival rate was 99.8%. The success rate was 100%. When Douglas Morrison stepped off Omaha Beach at 06:30 on June 6th, he had been awake for 31 hours. His hands were still shaking from exhaustion and cold. He watched tanks rolling across Ramp 6, the structure his company built in complete darkness. The ramp held, the tanks kept coming. Behind them, the invasion fleet stretched to the horizon. Morrison later wrote in his engineering report, "We built it because we had to. The alternative was failure. There was no alternative." The Germans called it impossible. The Allies called it Tuesday night. The 14 emergency boat ramps of Dday remain the fastest large-scale engineering deployment under combat conditions in military history. 14 structures. One night, 0 failures. The dawn revealed what darkness had built. Claude is AI and can make mistakes. Please double-check responses.